Chapter 3, problem number 7. Let me read the question completely first, then I'll show you how we lay out this problem and solve for a solution. Question number 7. A ball thrown horizontally at 22.2 meters per second from the roof of a building lands 36.0 meters from the base of the building. How tall is the building? Okay, first I want to lay out an X direction, a Y direction. The little red ball is going to be thrown off the roof, and we'll imagine this is the roof here, and this side will be the building, all the way down to here. And the question is, how tall is this building? We'll call that Y equals what? Because if we call this the Y direction, this is what we want to find. Now the ball is thrown off the building, and of course the ball will fall down and hit the ground over here. And they give us a direction. They say it's going to fall X equals 36.0 meters from the edge of the building. So if this is your edge of the building, it'll land 36 meters. And they said we throw it with a speed VOX equals 22.2 meters per second. So you have VOX in this direction. We'll define VOY in this direction as 0, because there is no VOY when you first throw the ball horizontally. The X will be 0, X naught is 0, and Y naught is 0. And we want to find how tall is the building, or we want to find Y. So the first thing we do is we recall our equations of motion. We have two of them. You have an X direction equation of motion, which is X equals X naught plus VOX times T plus 1/2 AX T squared. And in the Y direction, we have Y equals Y naught plus VOYT plus 1/2 A of Y T squared. Now, looking at our equations of motion again, let's plug in our numbers. Let's let AX equals 0, X naught equals 0. Therefore, X equals V naught XT. And you can convince yourself, if you've got 0 here and 0 there, you're going to end up with X equals X naught T. For the Y direction, our equation of motion is here. We're going to let AY equals G, the gravitational acceleration. Y naught is 0. V naught Y equals 0 in the Y direction. This equation then reduces to Y equals 1/2 GT squared. Now, transferring my two equations of motion to another piece of paper here, I want to calculate T, and we're going to know that T is equal to V naught X divided by X, and then putting in the numbers from our graph, we have 22.2 meters per second divided by 36.0 meters, and we'll get a T that's going to look like 0.61666. Now, I'm not going to round off at this time. I'm going to use the full calculator number because we don't want to introduce any other error just yet. We round off only at the very final answer. We take our time and we put it in the equation of motion for the Y direction, and we get 1/2 9.80 meters per second squared. By the way, this would be seconds. Meters per second squared times 0.61666 seconds squared. Now, if you do that on your calculator, you will get an answer that looks like 3.021666, and that will be meters because the seconds squared cancel out, leaving the meters. And this will be our Y, but this is too many numbers. This is very important. Remember, we started with 3 significant figures here, 3 significant figures, 3 significant figures. So we want to reduce our final answer to 3 significant figures, 3.02 meters. And that is how high the building is, 3.202 meters. So final recap, we find our y is 3.02 meters, and that would be the answer here. 3.02 meters is how tall the building was that you threw the ball off of.